Okay, welcome everybody. This is my talk, Achieving Cloud Agnostic Application Deployment with Habitat. My name is Scott Ford. I am a Principal Solutions Architect for Chef. I've been with the company for 4 years now, based out of the San Francisco Bay Area. And my journey to this talk really started 4 years ago. Whoops, come on. Yeah, there we go. 4 years ago, here at ChefConf, ChefConf 2014 was my first week at Chef, and right after that, I went right out into the field and started working with customers and helping them be successful with Chef. And it was really interesting because the first customer that I went to was a long stint. It was about 3 months, and we happened to show up on site at the same time that there was a new chief architect, a whole new infrastructure team, and they were all responsible for automation. And on this very first day that I got there, this chief architect stood up in front of the entire company, pulled everybody in, and we were invited to come in too, and he talked about this vision that he was trying to get to. This vision where they could quickly deploy out their applications into any environment. We need to be cloud agnostic. We need to be able to provision into AWS one day because of X, Y, and Z, and Azure another day because of X, Y, and Z, and Google Cloud, and so on and so forth. And we worked with them. This is right at the time too. I don't know how many people out there in the community remember Chef Metal, which became Chef Provisioning, but like that was hot right, for us. So this is before Terraform, of course, too. And so we dove right into that and started talking about it, started working with with this particular customer, and started to have some success, but didn't ever quite get there. And I can tell you now, 4 years later, that still was not something that they fully ever achieved. Like they were not cloud agnostic. But I left that company and I went to another one, and I was there for another 3 months. And the exact same story came up. They said, we want to be cloud agnostic. We want to go into this cloud on this day and that cloud on the other day and on-prem, and we want to have this thing all figured out from end to end. And so we started doing the same thing. Yes, automation is absolutely critical, right? So we got to bring up automation. We start using Chef Provisioning again. We kind of get there, but we don't quite get there, and it falls over. So what is it? Like, what is about cloud agnostic, first of all? I mean, how many people here work at a company where you have an initiative to be cloud agnostic? Yeah? Right? I think there's a lot, right? And the reasons behind that, right? There's probably lots of different reasons, right? Price might be something. We don't want to have vendor lock-in. They're kind of getting to the point that there's feature parity across all the clouds, and there's different reasons, right? So something else that I think has been preventing us, like, there's, with this feature parity, I can spin up infrastructure, I can, bring up databases as a service, all kinds of different features and so on. But the thing that I think that I'm kind of getting to now after 4 years of looking at this is that we've been looking at the problem from the infrastructure first and foremost. I mean, at least, sure, that's where I come from, so I was spending a lot of time in the place. But we think about the infrastructure coming up online, getting that all right, and then we talk about the applications that need to get deployed out into those environments. And it's really completely wrong. Like, the whole model is flipped, right? Because no customer has ever gotten value from some platform, from you using Red Hat or you using CentOS or Amazon Linux. Doesn't matter. Your CEO doesn't care about it at all. What they care about is that the applications that you're delivering are, you have a sane way to deliver them out and deliver tons of value, get feedback on whether or not your applications are doing what they're supposed to do, and when they are, double down on that, and the things that are not working, get rid of it, right? So cloud agnostic, I think, is something we can achieve, but we certainly have to have a standard way for that change to flow out from left to right. Screw this thing. All right. So if you've worked with us, if you've worked with Chef, we've always talked about this whole flow from left to right. So if I'm going to be able to get to the point that I can deploy my application out into any cloud, I first of all have to be able to have a sane way to build and test my applications doing local development. So what are the things, right? I need to understand how to build my application, what's configurable about it, how do I run it, How do I reconfigure it? How do I health check that application? When I have something, and I should be able to deploy that application on my local laptop. I should know that it works. Once I have that, I should be able to check in that change to source control. Source control should kick off a pipeline. Pipeline should build me an artifact and deploy to some kind of an acceptance environment where I can test that out. And if that looks good, then I need a way to promote that onto production. So I'm going to spend most of this time talking about Habitat and building applications. Most of this is going to be around demo stuff. I've got a lot to cover. So I'm going to jump right into it. Now, if you liked what you saw on the main stage, I'm going to build off of that and go in deeper to the code and the patterns of how we go about building things. So what you saw today in Nell's keynote demonstration was that she took this application, this sample application. It's called National Parks, and it's a Java Tomcat application. And typically, right, if we were going to deploy a Java application, I'd be a Java developer, and I'd work in Eclipse and build a WAR file or a jar file, whatever it is, and then somebody would go and install Tomcat on some infrastructure for me, and then build my artifact and go and deploy that out into Tomcat. Now, in this case, when you're working with Habitat, Tomcat's just a dependency. So I have in front of you right now in my editor, I have what's called a plan file. Now, Habitat, every application you build starts with a plan and describes that application, how you build it, what's configurable about it, how you describe its life cycles again. So how do I initialize that application? How do I run that application? And once deployed out, there's something called a supervisor, which manages the application's life cycle. The supervisor can handle things like different topologies, leader-follower. It can handle things like binding to other instances of Habitat applications, like databases, where they can pass configuration back and forth between each other. So in my repo on the left here, I've got my source code. I've got my Java source code. I've got a pom.xml for Maven to be able to build out my Java source code into a WAR file. But I've also got this Habitat directory here. Now, when you install Habitat on your workstation, you get something called a studio. So have studio enter. And the studio is a clean room for you to be able to build out your applications. What this does is it guarantees that nothing that I have configured on my lap, any specific versions of anything, are going to affect the build of my artifact. So another developer can go and pull this plan down on their local laptop, enter the studio, and they're going to have a clean room as well. Now, when you enter a studio with Habitat, it mounts up the directory that you started the studio in. So you can see here, again, I've got my Habitat directory, I've got a source directory, this results directory. And from there, I can run a build. I can just run build. And what this is going to do is it's going to read in my plan file, and it's going to go through and it's going to pull in these dependencies. So on lines 7 and lines 8, you can see that I've specified my runtime dependencies are that I need core Tomcat 8, and I also need Java in my inside of my artifact as well to run my Java code. So I depend on core Tomcat 8 and core JRE 8. Now, I should also specify that the core is an origin. That's who built the dependency that I'm declaring right there. And the maintainers of Habitat have their own origin called core, where there's lots of different libraries and applications that you can depend on and get going with your applications. My origin is Scott Ford there. But on line 8 there, I have what are my build time dependencies, right? So it's not uncommon that you see that when we deploy out applications that we actually bundle up our build time dependencies as well and deploy them out onto target environments. But why? Why do you need to have your build environment on your runtime environment? With Habitat, I declare that I need my core JDK 8 and I need Maven to be able to build out my source code. But that's not going to be a part of the package that I actually end up deploying out. So Habitat's going through and it reads these dependencies, core Tomcat 8, core JRE 8, Maven, and so on. But you'll see that it's actually now pulling down all kinds of other transitive dependencies. So my application, I know every single library that my application needs, all the way down to glibc and the specific versions that are going to be built with this particular artifact. And when this comes together, so it's right now it's still pulling down, dealing with some conference Wi-Fi. But when this comes together, I'm going to end up with an immutable artifact that is my application, its configuration, everything about its lifecycle hooks, that I can then go and deploy out into a target environment. Now, Nell today deployed out the national parks into Kubernetes. And the way that she did that was she, first of all, built this plan, and at the output of it got a habitat artifact. It's called a heart file. And from there, you can export that heart file into different formats. You can export it into Kubernetes and into Mesosphere and into Pivotal's Cloud Foundry, into Helm charts. You can do all kinds of things. But the heart file, all I need is the habitat binary running on, in this case, since my target environment is Linux, I need 64-bit Linux. I think the kernel version is 6.2.32 or higher. 64-bit Linux of any flavor, and this artifact will run the same way that it runs on my local laptop. So we're almost to the point right now, it's just finishing up, and now at the end of that, I've got a build. So I've got a brand new artifact that's here in my studio. So results, this nationalparks.heart file. That is the artifact which I can go and deploy. Now, inside of this plan file, you can see here that I've specified that my application expects a bind to run. If I go to deploy this right now and I don't bind it to a database, it won't deploy. So the Habitat Supervisor, when I deploy this, will expect me to bind it to a database. Now, I've already built out MongoDB for this particular application. Now, the artifacts that we build can be pushed up to a depot. We have a public Habitat depot, but as we announced today on the main stage, you can also get private depots for on-prem. And you can stand them up and have them totally isolated from the outside world. So I'm going to show you that inside my studio, I don't have to be inside the studio, but I can query the depot for packages. Hab pkg search, if I spell it right, Scott/np-mongodb. And so I've got a bunch of different versions. But which one of these versions? Hab pkg channels, that particular version. Copy paste. Artifacts that you push up to the depot can belong to different channels. You can tag them with channels. And at the time you deploy out your application, you can have the supervisor subscribe to channels and only load the ones that you want. So what I'm going to do first of all is I'm going to load up MongoDB inside of my studio. So hab sup status shows that I've got no services loaded. There's nothing running on here. But I'm going to go ahead and load hab svc load Scott/np-mongodb. And what this will do is it's going to go out. I didn't specify a channel in this case, so it's just going to grab me the latest stable version, and it's going to pull that down from the depot. And once it pulls down this artifact, the supervisor is going to start it. And if I run a sup log, you can see from the output that the Habitat Supervisor started MongoDB, it's imported my data, and that's ready to go. Hab sup status. Now, the output from this shows me that I've got MongoDB running, and it's running in a group here. So np-mongodb.default. That group is what's called a service ring. Habitat supervisors can bind together into a ring, and they communicate with each other and gossip. And they can pass configuration, but they will only pass configuration with other instances inside their own service group. So this right here now, with my artifact that I built previously, if I ls that results directory, this artifact right here, I can launch this inside of my studio and bind it to that database using that service group. So hab svc load results -- bind, database, right? So it says right there, database, I'm going to connect to a database. That's just an arbitrary string, np-mongodb.default. All right, now again, tail the output, sup-log. We can see that National Parks has deployed out, and if I open up a new browser tab over here and go to localhost, there's that latest version that Nell showed on the main stage, right? So this is all running on my local laptop. So back over here, right, we solved this first thing, which is on your local laptop, you can build any application. And I say any application, I really mean any application. My friend John Cowie and I have been working out with a big auto manufacturer on the East Coast. And one of our first applications we went out there to habitize, they had a huge legacy COTS application challenge, getting these applications into their brand new data center. And we said, give us your nastiest one. We want the hardest one, right? If it's easy, no one's going to believe that what's possible with Habitat. We took a Windows application written in Delphi in 2003, actually 2002, that was deployed on Windows 2008 R2, and we packaged it with Habitat, and we deployed that out into the cloud, and then as well as running as a Windows container. So, oh, and the application was written in Portuguese, too. We don't have anybody from our company who speaks Portuguese, but Google Translate helped out a lot. So this experience on your local laptop can be done with modern applications, brand new Node.js, Ruby applications, whatever you want to do, but as well as legacy Windows COTS applications, too. So we got this first part now. Now, in the interest of time, I don't have we don't have the time really to kick off a full build, but we also showed on the main stage that we've got this build service called Builder, which you can sign up for an account for. All you need to do is connect your GitHub account to it, and you can connect up repositories, repos to Builder. And anytime you make a change on your local laptop, push that up. It will automatically kick off a new build of your artifact and publish that to the unstable channel. Now, what I'm going to do, just in the interest of time, is I'm going to switch back over here, and I'm just going to go ahead and upload this new artifact that I just built on my local laptop. habpkg upload results. Okay, so it's uploading to the depot. Now this is the point that, like, you know, ideally all that you'd want to do via pipeline, right? Test that all out. But I now have this new artifact up here, and if I run habpkg channels on that artifact, you can see that it's only part of the unstable channel. Now, what I've done before this is I used Terraform and I provisioned out a bunch of infrastructure. I provisioned out 6 nodes, and I have an acceptance node that's running in Amazon on Amazon Linux production, Azure on Ubuntu Linux, acceptance in production, and then Google Cloud on RHEL, an acceptance in production. Now, I told you before that all I need on those instances is the Habitat binary, and once that's on there, those 2 packages that I showed you, the MongoDB and the National Parks, will run the exact same way that they ran on my laptop in the cloud, anywhere. Doesn't matter. So what I'm going to do right now, though, as you're going to see, is I've got National Parks loaded up. Here's my GCP acceptance, my Azure acceptance, my Amazon Linux acceptance. They're all listening to the acceptance channel and are on this version that's out there. So let's go ahead and let's promote these. Promote this new one. habpkg promote this to acceptance. And once we do that, switching back over here, I've got terminals open on my instances. And you're going to see some other stuff going on that, again, my friend John Cowie and I have been working on, which is Chef clients running there in the background. And what you're going to see here is that every minute, these instances are pulling the Habitat depot. And as soon as it recognizes that this new artifact has been promoted to the acceptance channel, Habitat is going to redeploy my application. Now, there's different update strategies. I have mine just redeploying on at once, but you can do rolling deployments across your infrastructure as well. And so it should be just a minute here. So acceptance, acceptance. Okay, there we go. So there we go. Azure's just redeployed itself. You can see it's redeploying on the latest version. So if I switch over here to Azure, my acceptance environment, that's GCP. There we go. So that's redeployed itself now. Check on the other ones. There we go. Google Cloud has done what it's supposed to do, and Amazon Linux, how are you? There we go. Okay, cool. So we've now satisfied this, that we can go from our laptop, we can go have a sane way to test that all out. I could submit that change to source control, which can kick off a pipeline or the build service, build me out an artifact, and promote it. And as soon as it promotes, it's going to do what it's supposed to do the same way it was on my local laptop. Now, I'm happy with this. Let's go ahead and let's promote this out to production. And sure enough, my production nodes on the bottom should do the same thing here. We'll see it recompiling the hooks and redeploy itself out onto the latest version. So should be in a minute now. Okay. Waiting for just a minute. Okay. Did I spell production wrong? Did I fat finger it? No, it's good. Maybe it happened so fast I didn't even see it. Not quite yet. Okay. In the interest of time, I'll keep going. It should redeploy itself pretty quick here. So the other thing too, so if we're really going to achieve cloud agnosticity, if we're really going to do that, our infrastructure is just a dependency of the application. So we should have a sane way. And you know, like if you've been working with Chef for a while, you know that we put a lot of focus on the local development experience with that. You've got Test Kitchen, sane way to build out cookbooks. You can run InSpec in there, and you can test the infrastructure that you're standing up. But what is it about infrastructure? If we can package up our applications and deploy them out, what are the common things that we need to have on infrastructure, right? So it needs to be hardened, right? It needs to be tuned. It needs to be patched. NTP is a good thing to have. Authentication with things like LDAP and Active Directory, right? Those are the basics. Like that's a pattern I think that we could build on, right? So the last 6-7 weeks has been really interesting for us because we've gone off on this new journey to really explore what's possible there when we think about infrastructure as being a dependency of the application rather than the thing that we start with first and then deploy out applications onto as well. So double check on this thing because if it doesn't, there we go. All right, there's production. All right. I think probably other people are hitting the build service as well right now. But okay, so Habitat, what you saw on the main stage today too, was the output of that work as well. So what about Chef Client? Chef Client's just an application, right? Why not package the Chef Client up with Habitat and deploy it out and then take advantage of those things, same things, the channels where I can promote my application through different environments and so on. So what you saw today looked something like this. I've got a Chef Client repository here. And inside that repository, I've got a cookbooks directory, right? That's pretty common. We've got a policy files directory. How many people use policy files out there? Yeah? Actually, that's more hands than I expected to see. Policy files have been around for a while, and it's a great idea, but it just hadn't quite caught on. The idea is that you can create a policy file and you can lock in all of your cookbook versions, your attributes into a JSON file.lock that you can move throughout your environments and be guaranteed that these are the cookbooks. So if you've ever dealt with dependency hell out there, policy files are a great thing. But delivering that now inside of building it with Habitat and deploying it across your infrastructure is a really, really cool thing. So we've got in here as well as we've got our Habitat directory. We've got our plan file, which describes how to build out our applications. And once I deploy this out, I can get my nodes reporting into Chef Automate. So, and at the same time, I can have it run all of my compliance profiles as well. How are we doing on time? Okay, good. So we got 6 nodes, and they're not passing compliance, right? So all those nodes right there are not passing compliance. I've got 2 profiles running out there. I've got the DevSec security baseline, and I've got my Linux patch baseline. So let's see if we can fix this, right? So I've got over here my policy file, and I'm just running my base policy file. And my base policy file right now, the run list is only running compliance. So let's go ahead and let's update this to run our patch. And we'll have it run our hardening cookbook. All right, looks good. Is that right? Double check the name of that patch. It is patching, good. And we'll go ahead and do a build. But wait a minute, there's one other thing though, right? I don't know if anybody saw this, but this is Automate 1, right? What kind of a chucklehead brings an Automate 1 to an Automate 2 release party? Right? So let's do this. I launched out Automate 2 over here. I don't know, that's somebody else's. Automate Scott4.io, that's me. All right, we'll say admin example. I've logged into this once, but I haven't done anything with it. And this is where the demo gods, I pray to you, work with me. All right, so I've got now Automate 2 launched out here with Terraform this morning, and it has nothing reporting into it. It doesn't even have yet a data collector token to be able to receive data for my instances. So let's go ahead and create that. Data collector token. We'll generate a new API token, and I'm going to go ahead and I'm going to copy that. Then coming back over here to my policy file, I'm going to update this to report into Automate. And then I got to do one other thing. Oh yeah, my plan. My plan has a token. Let's go ahead and blow this away. All right, there's my token. And let's go ahead and update this as well to Automate. All right. Okay, cool. So same thing, right? We should have a sane way to build out our artifacts as well. Why should they be different, right? So for this particular thing, I use an environment variable. So I have multiple policy files. I use an environment variable inside the studio to tell it I want to build the base policy. So I say env chef_policy file equals base build. I'm in the wrong place. So if you saw the studio mounts up in whatever directory that you start in. So I wasn't inside of the chef clients directory, so I've got to go in there first. And now I can run that same command again. And it's going to read in my plan file. It's going to grab that latest. It's going to do a chef install of the policy file. So it's going to collect all of my cookbooks, all of their dependencies. It's going to load that into an artifact. It's going to export that into a new Habitat artifact. And that will contain all my cookbooks, my config.rb to point to the right Chef Automate server. And once we're done, we'll have the same way, we'll use the same way to go ahead and update our infrastructure. And hopefully we should see it patched, we should see it hardened, and we should see it reporting into Automate 2. So here we go, it's executing the policy file, it's running the hardening, the compliance, the patching, so I'll grab all those cookbooks now. It's caching the cookbooks. There we go. I know all the versions of my cookbooks that we're using. Oh, conference Wi-Fi. So this pattern is something that we're really excited about. Like I'm going to, we'll update all the, make all the code available for it, but we're definitely looking forward to working with people in the community that are interested in this and building out. Like this is the basic things that we think we needed for a core operating system, but love to get feedback from other people on that. Okay. Now the other thing too that I don't have time to demo for you is how many people love Test Kitchen out there? Yeah, I expect to see a lot of hands. This pattern works with Test Kitchen too. So what we've done here is inside of this repo, we also have kitchen YAML files that will load in the habitat artifact that you build here in your local development environment, so you can test that on a system in your local development environment too. So you shouldn't have to change the ways that you do things to be able to test this all out. So great, so we've got a new artifact, and we're just going to go ahead right now, instead of testing that out, we're going to push this thing up, hab pkg, upload that new artifact to the depot, send it on up. It's up there, and now let's go ahead and let's do a hab pkg promote this one to acceptance. Cool, and let's see what it does. Right, so all my acceptance nodes are across the top, and we should see them say initializing. The supervisor should pick up that change here within a minute. It should reinitialize itself, pull down that latest. There we go, it's running. So my Azure node is recompiling and redeploying itself, so let's, fingers crossed here. There we go with GCP, it's doing what it's supposed to do. Come on, Amazon, it's a race, it's a race. All right, Amazon's doing its thing now, it's redeploying. Here we go for migrations. Come on. Did I miss something on the token? Come on, come on, come on. Yes! All right, it worked. All right, so we've just done half of it. We've got a migration that's in place. Did compliance work? Yes, we did. All right. So now we've got nodes migrating from Chef Automate 1 into Chef Automate 2. And this time through, when they come through, they are patched and they are passing compliance. And this is just an example of this, right? But whatever your patching, or whatever your compliance strategy is for your company, you can enforce in the same pattern as well. So I'm going to go ahead and I'm going to see here. We should have the rest coming through. I'm going to go ahead and promote this out to production and let production do its thing as well. Excellent. Okay, cool. Should be just 1 second here. We should see the production nodes start to do their thing, and pretty soon we should have everybody checking in. So, all right, GCP is starting off now. Yep, so GCP is running the hardening right now. on the instance. Amazon, you're slow today. All right. I spent a lot of time with Terraform and on all these clouds, and I definitely have some opinions now after the last few weeks, for sure. GCP is pretty awesome. It's fast. Okay, so we should now, if we come back over here, I want to make sure we see at least a couple of production nodes checking in. We've got all 3 of our acceptance nodes. We've got GCP production is checking in as well. So anyways, this is the thing now. Whether it's applications, whether it's infrastructure changes, you should have a sane way across your company to be able to test out those applications and infrastructure changes and move them across. What we're finding right now is Habitat does it, like across the board. If you're doing Windows applications, if you're doing modern Linux applications, you can build them the same way on your laptop. They'll run the same way on your laptop that they do once they're deployed out into any environment. And when I say that, like really export it out where you need to run it, manage it in the same way once it's deployed out there. And this pattern too, infrastructure is just a dependency of your application. So you too should have a sane way that you can build out your infrastructure changes and move them across your environments into any cloud. So that's it. I want to say thank you. I definitely want to call out John Cowie, the bunch of Adam Jacob, a bunch of people from the team, John Snow, David Eccles. There's been a bunch of people that we've been working on this as well. And thank you. I'm going to stand up here for questions if anybody has. Thank you very much for coming. Yeah. Okay, so the question is, how do you deal with multiple databases when you want to move databases across the cloud? So one of the interesting things that we've worked on at a couple of different places, and this is a little bit, can be a little bit abstract, but in Habitat, you can build packages that's their only job is for configuration, is to pass, like we've had companies that use, say, Oracle database or RDS, and like, what do you do in that case? So what we did was we built a really simple package that's just called a stub package. And a stub package just has a plan file and a configuration file, default TOML, that has some things that you might need to connect to your database, password. And for the supervisor to be able to chew on something, we just create a really simple run hook. And the run hook is just a while loop that says while true, sleep 5,000. And so it'll just sit there. And I showed you the pattern of binding applications to databases. Well, what you can do is you can take your Habitized application, you can bind it to this. And at deploy time, or even after this stub is deployed, you can inject the configuration dynamically to supply these configurations. So if you want to migrate to a different point, you update the stub. And the stub will just say, now talk to this database over here. So that's what we've done, and it's really cool. Works really well. Okay, well, thank you very much.